Assalamualaikum warahmatullahi wabarakatuh and good morning. First of all, I would like to introduce myself and my name is Nurfatin Shafika. I am from Group 8 and today we would like to present our project-based learning. So, this is our group member. Here we have Daniel Farhan, Ahmad Mukri, Farin Hakim and me, Nurfatin Shafika and also Akaisa Ami. Okay, next, in this presentation, I will show a introduction and we will present and discuss about a problem statement that have been given, which is 8.1 and 8.2. And we also will discuss about a filler table and also a solution based on the problem statement given. And at the end of this presentation, I will conclude what we have been doing and what we have got in this PBL, which is project-based learning. Okay, next, in this PBL, which is a problem-based learning, we will be tested in critical thinking, a problem-solving skills, and also a collaborative learning among our group. And also, this PBL will also highlighted the practical application of mathematical concept in real-world context, reinforcing the relevance of mathematical education in life. We will also discuss how to solve a problem by using the mathematical method that we have practiced in class into our daily life.
Assalamualaikum and my name is Farin Hakim and today I'm gonna explain the solution for 8.1, which is the question related to the rocket altitude, which it says what is the rate of change of altitude after 4 seconds. So we're gonna take a look at the solution. So first of all, the given equation is ht equal to 80 te the power of 0.2 t minus 5t squared. So first we're gonna split the equation into two. So it's gonna be h prime t equal to d over dt. No, sorry. First of all, differentiate it. 80 te the power of 0.2 t minus 5t squared, and then we're gonna split it into two, which is d over dt. Bracket 80 te power the power of 0.2 t minus d over dt 5t squared. So for the 80 te the power of 0.2 t, we're gonna apply product rule. So it's gonna be 80 bracket d over dt t times by e the power of 0.2 t plus t times d over dt in the bracket e the power of 0.2 t. So both of that, we're gonna split it into 80 in the bracket e the power of 0.2 t plus 0.2 te the power of 0.2 t. So we will get 80 e the power of 0.2 t plus 16 te 0.2 te, which is we differentiate both. We actually expand both. We expand 80 into e and 80 into 0.2. So after that, we're gonna differentiate it, which is h prime t equal to 0 e the power of 0.2 t plus 16 te the power of 0.2 t. And then next, we're gonna differentiate the second terms, which is the negative 5t squared. So we will differentiate the negative 5t squared and we will get negative 25t. So at the end, we'll get 80 e the power of 0.2 t plus 16 te the power of 0.2 t minus 10. So in the question, it is given that t is equal to 4, which is after 4 seconds. So we have to substitute the t with 4. So it's going to be 80 e the power of 0.2 times 4 plus 16 te the power of 0.2 times 4, and lastly negative 10 times 4. And approximately we will get 280 and 478 meter per second. That's all from me. Thank you.
Assalamualaikum. My name is Daniel Farhan. Number matrix DAE23000328. For my part, I will talk about filler table 8.1. So from the question 8.1, we get to find 4 sets of answers for filler table. So for the first set of answer, altitude function ht minus 80t e with the power of 0.2t minus 5t square. From the fact, we get to find the idea, which is to find the rate of change of altitude. We need to differentiate the altitude function with respect to time. So for the learning goals, how to differentiate a function involving both polynomial and exponential terms with respect to time. So for our action, we we can differentiate the altitude function ht with respect to time to find dh over dt. For the second set of answer, given time is t equals to 4 seconds. From the facts, we get the idea that the rate of change of altitude, which is dt over dh, represents the velocity of the rocket at any given time. So for the learning goals, understanding the concept of instantaneous rates of change and its physical interpretation in the context of the rocket's motion. So for our action, we can substitute t equals to 4 into the derivative of ht to find the rate of change of altitude after 4 seconds. Next, for the third set of answer, fact is derivative of altitude function, which is dh over dt equals to 80e with the power of 0.2t plus 16t e with the power of 0.2t minus 10t. From that, the idea we can think about is the rate of change of altitude gives us information about how fast the rocket is ascending or descending at any given moment. For the learning goals, applying the derivative of a function involving both polynomial and exponential terms to solve real-world problems. So for our action, we can evaluate the derivative at t equals to 4 seconds to determine the rate of change of altitude. So for the last set of answer for filler table 8.1, rate of change at t equals to 4 seconds is 280.47 meter per second. For the idea, we get to know that the answer is 280 equals to 478 meter per second. So for the learning goals, we can understand the significance of the rate of change in analyzing dynamic systems such as the motion of the rocket. So for our action, relating mathematical concepts to real-world scenarios and applications.
Hi, my name is Kaisamni binti Shahrunizam. I will be explaining question 8.2. The question is, an engineer is tasked with designing a cube-shaped satellite where all faces are covered with solar panels to maximize energy absorption. The satellite sites are expanding at a rate of 2 cm per second due to exposure to solar radiation. The surface area of the cube is given by S equal to 6x squared, where A is the length of a side of the cube. The question wants to determine the rate at which the total surface area of the satellite is increasing when each side is 50 cm in length. How does this rate of change impact the efficiency of solar energy absorption over time? From the question, we know that A is equal to the length of the cube side, where S is equal to the total surface area. The question wants to determine the rate of total surface area increasing over time, which is the ds over dt. It's given that the satellite sites are expanding at a rate of 2 cm per second, which is the dA over dt. Now to find ds over dt, we only have dA over dt. So we use chain rule. Thus, dA over dt multiplied by ds over dA equal to ds over dt. To find ds over dA, we differentiate the equation s equal to 6s squared, where we will get ds over dA is equal to 12a. We substitute the value, then we get ds over dt equal to 12a multiplied by 2 equal to 24a. The question wants the rate of the total surface area over time when the A is equal to 50 centimeter. So we substitute the value into the finalized equation, then we will get ds over dt is equal to 1200 centimeter square per second. The question also asks, how does this rate of change impact the efficiency of solar energy absorption over time? We know that the increase in the satellite surface area, and hence the area covered by solar panels, directly impacts the efficiency of solar energy absorption. As the surface area increases, the satellite can absorb more solar energy. This is because the amount of solar energy absorbed is proportional to the surface area exposed to sunlight. When the satellite surface area is increasing at a rate of 1200 centimeters square per second, the amount of solar energy it can absorb also increases proportionally. More surface area means more solar panels can capture sunlight, converting more solar energy into electrical power.
Assalamualaikum. My name is Ahmad Mukri Naim. So I will explain about filler table 8.2. So the first facts, the surface area of the cube is given by S equal to 6A power of 2. Then the idea is find the derivative of the surface area equation. The learning goals, understand how to differentiate polynomial equation, and then the action, differentiate the surface area equation with respect to side. Then second facts, rate of change of satellites surface area per time, ds over dt equal to ds over dA times dA over dt. Then the idea, substitute the dA over dt equals to 2 and ds over dA equals to 12a into the differentiated formula. Then the learning goals, apply the chain rule formula to solve the problem involving rates of change. Then the action, research formula for the change rule calculation. Then third facts, each side of the satellite is 50 cm in length. Then the idea is A equals to 50 cm. Then the learning goal, learn to identify keywords by analyzing the question. Then the action, use the value to substitute it in the finalized derivative of ds over dt. The last fact, solar energy absorption is proportional to the surface area exposed to the sunlight. Then the idea, long term energy absorption will continue to rise with surface area, but depends on the maintenance of panel efficiency and effective power management. Then the learning goals, explore the relationship between the surface area of solar panels and energy absorption. Then action, ensure the satellite's structural integrity to handle expansion and maximize solar panel exposure. Thank you.
In conclusion, in our studies, we use a problem-based learning to tackle problem N, which encourage critical thinking and also collaboration. By applying maths into a real world, we highlighted its practical importance in engineering and also science. This improved our communication skills and emphasized the value of teamwork. We also learned that math is crucial in fields like aeronautical engineering and satellite technology for optimizing designs and ensuring efficient performance. For rocket, we knew how to calculate accurate altitude, and for a solar energy absorption, we knew how to optimize a surface area. In summary, our study underscores the importance of math education in engineering. By applying maths into a practical challenge, we gain valuable insight and prepare for professional issues. This emphasizes the need of collaboration, critical thinking, and effective communication in education and also a career. So that's all from us. Thank you.